My name's Bruce Wallace, and I lead product management for a bunch of Nokia's data center oriented products. So, kind of the main two that I'm the lead PLM for is SR Linux, which is our operating system that we run on our switches, and Event-Driven Automation, which is our infrastructure automation platform that we launched last year, and why I'm here, obviously. It's hard to hit all the value props in a single question, but Nokia Event-Driven Automation at like a super high level is an infrastructure automation platform that's kind of designed for the modern, NetOps, DevOps era that we currently live in. So it's kind of been designed from the ground up for things like streaming telemetry, for kind of intent-based automation, the typical like closed loop stuff that others in the industry have been talking about for a while. Some of the nuance, some of the stuff that I think is like our secret sauce, we kind of lean heavily into Kubernetes and kind of using that as a platform for more than just managing workloads. In our case, actually, you can manage your entire infrastructure using Kubernetes if you so wish. We also focused a lot on reliability, which I'm sure we'll talk about more. But the whole theme that device and human interactions have like never been more important. They've never happened more frequently than they are today, just based on the churn we're seeing in the IT space. So it's never been more important for those interactions to be reliable. And that's kind of where we've invested, I would say, the vast majority of our time is trying to ensure those interactions can be reliable, which of course leads to a higher, you can roll out more changes faster with higher confidence that they're going to work, all of that kind of good stuff. So we're kind of initially targeting this platform at data center enterprises, that kind of market, but the platform itself is super generic. We don't call it like necessarily even a data center automation platform. It truly is kind of a generic infrastructure automation platform. We just happen to be kind of biting off data center as our first use case. I think I would break it into a few different areas. The first is that whole like device to machine interactions that we're experiencing a lot more of. I think when you look at an automation platform that needs to look kind of more holistically, not just at a device level, what does it mean if you roll out a change and it goes to 9 devices, but not all 10? So I think there was a lot of time we spent on just kind of this idea of atomic change sets that get rolled out at an infrastructure level, not at kind of a per device level. And if any of those changes were to fail, we kind of do these kind of, again, atomic rollbacks as well. So your entire infrastructure is kind of stepping forwards all at the same time, and that either works, and now that's your new golden state, or it doesn't, and you immediately roll back to the previous golden state. So it's this whole theme of having these golden states and being able to move from one to the other as you roll out, additional changes into your infrastructure. I think that's kind of a big theme that we've kind of hammered on around reliability. There's also a few others. So the platform itself is trying to basically give you these nice little abstract resources, something like an interface, or you can even imagine something more abstract like an entire data center fabric. You can think of that as being modeled using one of these abstractions. And those abstractions are obviously opinionated. So they're going to take away a lot of the complexity of like deploying a data center fabric, for example. And that in turn results in reliability, but just because the number of code paths to get to the result at the end is less. And so we've seen, just based on us having more opinions around what gets rolled out and potentially giving less ability to customers to have those opinions, actually helps a lot. And I think we have some questions later around open source. So I'll cover the antithesis of what I just said, which is you can't be closed off. You kind of need to be nice and open as well. So yeah, I think it's kind of, those are kind of the big themes I would think of around reliability. Probably the other is kind of that whole NetOps DevOps thing. If we look at the application world that exists around us, you're getting multiple updates delivered to your laptop for Microsoft products or Google products almost every day. And the reason they can do that is they do a lot of kind of CI/CD pipeline stuff where they can like roll out a change and have it run through a bunch of automated testing before any customers ever see it. And assuming all of your tests eventually pass, you have kind of an automated deployment into production. So we haven't typically looked at infrastructure through that lens before. And I think it is the first time we're starting to do that. Like we promote very much that whole, we'll give you a pipeline that you can run a bunch of pre-checks in, eventually roll out your change, and then run a bunch of post-checks after. And if any of those things fail, again, that whole reliable atomic stepping forwards and back happens. So I think applying some of the concepts we've seen in the surrounding application world, which has had to, adopt, I would say, a bunch of fairly emerging technologies just out of like bare necessity. They have to move fast. So we're starting to see that roll into infrastructure. And as much as those things help them move fast, they help them move fast reliably. So we're starting to bring that reliability down to the infrastructure layer. So I just finished saying that like we close everything off and we give you no choice. You have to do what we say. So the way we do that actually is using, I mean, I'll call them intents loosely, but you can imagine like the set of code that would execute and how you deploy a fabric. Let's call that an intent. We wanted to develop those intents themselves on top of a platform, and the intents themselves could be open source. We feel that it's really, really important when you're building a product like IDA, where extensibility and customers having the ability to change what the system does, like very much down to its core, you have to do that in kind of yourself in the open source community. So what we kind of have with IDA is we have what we call the IDA core, which is this, this is actually closed source. So this is like our secret sauce. And then on top of that, we've built a bunch of these intents, these abstract resources, along with their corresponding logic. And all of that we distribute in open source. So as much as you can look at what we did, this is how we deploy a fabric, these are our opinions, you can now take what we did, the literal source code, and change it, tweak it, make it work however you like. And then you can roll that into the system as like your version of our fabric. So that kind of build a platform, give tools to yourself to help you build these intents is kind of what we did. And then make sure that that same functionality that we leveraged can be leveraged by our customers as well. So I think that kind of gives us this like best of breed system where it's hyper extensible, but it can also be very, very opinionated. It can be very turnkey. If you're an enterprise that just wants to consume the set of intents that we bake in with the platform, you can do that. If you're the type of enterprise that actually really cares about things like specific BFD timers or which routing protocols are used in the underlay, you actually have that capability too. You can build that on top of the same framework that we're leveraging ourselves. So I think we've seen just a ton of traction in some of our other products just by engaging with that open source community, giving them tools to help them kind of just play around. We're probably the only vendor, I think, that still has a public container image for our operating system. We're the only vendor that doesn't have that behind a registration wall, behind a paywall, because we see the benefit of people getting their hands on our products and doing really interesting things. We've taken the exact same approach with IDA. So when we launched at the end of last year, there's a free version of IDA that you can play around with in your lab. You don't need to talk to anyone at Nokia. You don't need to register, nothing. It's hosted on the GitHub container registry. So I think, it's good for us just because that open source community is hungry. Like they want a platform like IDA. And it's also good for our customers just because they're getting kind of a best of breed platform with an unbelievable amount of extensibility. So if they want flexibility, they absolutely have it. When we started thinking about some of the early, I'm going way back when we first started designing SR Linux, we really wanted customers to be able to stage changes before they rolled them into production. Like we kind of already did this, like this process exists with like labs, physical labs, people roll changes into, they kind of write methods of procedure based on those labs, and then they roll them out into production. And often what they found, and I come from an operations background, so I can vouch for this, is the lab and your production network, as much as you might try to make them look the same, they never look the same. So what we really wanted to do with the digital twin is, for one, let's make our operating system nice and easy to containerize so that we can simulate it anywhere we like at very, very low footprint, including the entire control plane and having a data path there. And now with an IDA, let's actually give you the tools to, as and when you're rolling out changes, you can almost imagine that digital twin is now your pipeline to get into production. So we have a suite of automated tests that you can roll out into that digital twin, which again, on that whole reliability theme, it's all about making sure the change that lands in production is the change you wanted and has the desired outcome. So having an entire replica of your production network that's kind of aligned through the same single pane of glass that you're managing that production network through, with all the streaming telemetry that we have available to us in our operating system, feeding into that playground to make it look as true to production as you possibly could find, including state and everything, once you've rolled a change through that environment, that it's going to work at the other end. So again, I think it's just bringing some of those kind of CI/CD concepts that we've seen in the application world into infrastructure. And obviously, infrastructure is pretty complicated. You can't just say, well, here's my web server and here's my database, and I'll test these things together, because you have a very complex network and things are offline all the time. So yeah, there's different requirements for trying to create a digital replica of infrastructure, which I think we've been able to handily solve with the work we've done with EDA. The big things you need to ask yourself are like, what are the fundamental problems you're facing? And I suspect a lot of those problems are going to be around, well, I just want to move faster, deploy things faster. AI is the new hot topic. My CXOs are asking me to build AI fabrics and figure out what our on-prem language model strategy looks like. So you've kind of got two problems you need to deal with. One is we're going through a fairly unprecedented growth phase in data center, and there is still a ton of unknown of how that market is going to be, how it's going to mature, shall we say. Is it eventually just going to be everyone running language models in public cloud? Is there really a demand for a lot of on-prem models with very, very enterprise-specific business logic inside of them? I suspect it's some combination of these two things. So what we have focused on in EDA is making sure that you can react quickly, reliably to any change that comes your way, even if that spans outside of the data center. We're going through a time where, for the first time ever, there's real tangible benefits in automating the network alongside the GPUs, alongside the DPU, alongside the compute, being able to schedule workloads onto that set of infrastructure. EDA is kind of designed that eventually you'll be able to have this thing manage servers, you'll be able to have it manage DPUs, GPUs, the full stack. And I think if you are looking at other platforms that aren't imagining just where this market might go and being able to pivot quickly, you might paint yourself into a corner. So we have a ton of flexibility. This is like a brand new modern platform that is designed for basically automating everything. If you have an API, we want to automate you. So those would kind of be my main selling points. Obviously, I think the foundation here, like Nokia's claim to fame, really is one of quality. So despite us kind of bringing an innovative platform to market, it's coming to market with the same degree of quality that you would see in like these mission critical networks that we're kind of famous in. That's our pedigree. So you're getting that kind of carrier grade reliability with, just unbelievable flexibility for the unknown. Because yeah, there is a big unknown out there, and I think we need a platform that can react accordingly.